Hi, 8th graders. It's Miss Roberge here. I'm going to go over question number 2 from Investigation 1 for Mrs. Schmeel's class, and this is from Unit 4. So we are still looking at unit rate, proportional relationships, constant proportionality, and we're making some lovely graphs. So let's do this. Okay, let's look at number 2. It says, here are 2 ways to represent a situation. Description. The Origami Club is doing a car wash fundraiser to raise money for a trip. They charge the same price for every car. After 11 cars, they raised a total of $93.50. After 23 cars, they raised a total of $195.50. So probably one of the first things you're asking yourself after reading that is, how much did each car cost? So let's figure that out first, okay? So $93.50 was the total that they raised, and they had 11 cars for these first 2 values. So we would just do $93.50 divided by 11. You can use a calculator for that. I know you all have them, and you would get $8.50 as your cost per car if you did that on the calculator. So if we know that each car costs $8.50, and we have to write an equation in A here. A says, write an equation that represents the situation. Use C to represent the number of cars, and use M to represent amount raised in dollars. So let's go back to our table for a second. Remember that they're telling us to use C, and the money is M. And this would usually be X and Y. And when we write proportional equations, we're usually writing them as Y is equal to some number, an unknown number, times X. That's usually what we get. So that's the format we want to have this in. And that's why it was important to figure out the cost per car. Because if I have to use these, C and M, I needed this number. I actually had to look at this problem for a while myself to figure out how to write it correctly. So to write this equation, we're going to start with our Y value, 93.50 equals. Now, when I was trying to figure this problem out, I wanted to multiply the number of cars times C. But then I realized that didn't make any sense because the number of cars is C. That's given to us right here in all this information. So that wouldn't work for me. What I really have to do is multiply the cost, which we determined to be $8.50, times my C value. And then similarly, with the second numbers, I would be doing the same thing. $195.50 is equal to the cost per car times my C value, number of cars. Now, I would be willing to bet, oops, I meant to put C there, not 23. I would be willing to bet if I substituted my numbers in, which for this equation, the C value they told us was 11. And for this equation, the C value they told us was 23. If I multiplied those, I would get these. And yes, I would get those. Just to bring the M back into the equation, these could also be written as M equals 850C. Okay, now for part B, we get to graph this. So I blew up the graph here so that we'd have an easier time of seeing it. On the bottom, on the cars axis, we can just count by 1. So 1, 2, 3, 4, 6, 7, 8, 9, 10. That wasn't too bad this time, guys. I think I'm getting the hang of this. And then, remember, this is the same as x. And then on the m/y axis, I'm actually going to count by 25. I'm going to put it as 50s. So every 2, 50. 2 more, 100. 2 more, 150. 2 more, 200. All right, and then I'm going to take the numbers that we were given. So we were given 11 and 93.50, and we were given 23 and 195.50. And I'm going to treat these just like a set of points. And I'm going to go graph them. So for 11 cars right here, I go up to 93.50, which would be just under this 100. So I'm going to estimate my point is about there. And then I have to go over to 23, which is right here, and go up to 195.50, which is almost 200, right there. And then I get to draw my line. And I know this is not going to go perfectly. Let's see, guys. Oh, actually, that was pretty good. I hope yours is straighter than mine, though. And that's how the graph would look. And once it's graphed, it really does make a lot more sense. We see now the way that equation works at the number of cars and, I didn't label my y-axis, and the amount of money that they earned. They're dependent upon each other. And the more cars that we have, the more money we're going to make. So now we have to look at C, which says, how can you see or calculate the constant of proportionality in each equation? What does it mean? Well, we've talked about this. Constant of proportionality is calculated by doing y over x. And we did that. So let's go back to what we talked about right here. That was what we did. We did y divided by x, and we got 850. And what was that? It was the cost per car, which is also known as the unit rate, and that's an important term for you guys to know. But you just want to understand, that 850, what did it mean? It meant that each car cost $8.50. Let's look at our last one, which is D. Explain how you can tell that the equation, description, graph, and table all represent the same situation. We had a really similar question in the last part of the investigation. And just remember, we use the same numbers. We just showed them in a different way. And by putting them in the formula, by proving that they work through division, by graphing them and getting the line, by using the same numbers, that's our proof. We use these numbers in multiple different ways, but they all meant the same thing. And they all linked together. Our graph was dependent on the information that we got from the table. We couldn't have made the graph without that table, without some information from there. So really the points come together to make the graph. They're all linked. That's how they all represent the same situation. As always, I hope that this video finds you well. Hope your families are well, and I hope you're all hanging in there. And I hope to see you all soon. Have a great rest of your day. Bye.